Hey everyone, Mr. Armitage here, and in this video I'm going over an extra example of the rational root theorem, or using the rational root theorem. So here we are finding all real solutions of the polynomial x to the third plus x to the second minus 14x minus 24. So x cubed plus x squared minus 14x minus 24 equals 0. Now remember that our rational root theorem is saying that all roots of our polynomial are going to be in the form of, as long as we have integer coefficients, so whole number coefficients, all our solutions will be in the form of x equals plus or minus some factor of the constant term a0, so that a sub 0, the very last term, the constant term, divided by a factor of a sub n, so the very first term, or the leading coefficient, is what a sub n is. Okay, so this means that we need all of the factors of 24 and all of the factors of 1. Not mean to erase that. Okay, because the leading coefficient here is 1. So first off, the factors of 24. We have, now let's not worry about positive and negative right now. We have 1 times 24. Okay. We have 2 times 12. We have 3 times 8, 4 times 6, and that's all. So no 5s. All right. And factors of 1, well, that's simple. That's just 1. Okay, so these are factors of 1, and then these are factors of 24. So let's go ahead and we will list all of our possible factors. Okay, so we only have this 1 for the denominator, a sub n. Okay, so we don't need to worry about that too much, but we do have 8 different ones for, well, 24. So all of our roots, possible roots, or possible solutions, will be x equals plus or minus 1 over 1. Okay, so we did this one first. Then we will also have plus or minus 2 over 1. So there was that one. We'll have plus or minus 3 over 1. Next, 4 plus or minus 4 over 1. Then we'll do 6. So, oops, forgot the over 1 there. Plus or minus 6 over 1. Plus or minus 8 over 1. Then 12. So plus or minus 12 over 1. And 24. So plus or minus 24 over 1. So we can rewrite this and make it a little simpler, right? All our denominators are 1, so we can simplify this into just whole numbers. X equals plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Okay. all of our solutions to this problem are contained in this list here. Okay. Every solution we find will be in here. However, this also has numbers that are not solutions to us. All this does is tell us possible solutions, not what those solutions are. So we need to test it. And how do we test it? Well, systematically, using synthetic division. So we can set up synthetic division. Right? We can test if these are solutions using synthetic division, because we also know if we evaluate a function at its root, we will get a remainder of 0. Right? The output will be 0. Therefore, that means that that number is a factor as well. It all ties in together. So let's start systematically. Okay, we're going to start with plus and minus 1. Okay. So here we go. I will set up our synthetic division. Okay. And here we'll have positive 1, and here we'll do negative 1. Okay, now the coefficients of our original equation, x cubed plus x squared minus 14x minus 24, x cubed plus x squared minus 14x minus 24. Okay. Over here as well, because we have to do both positive and negative versions. All right, so here we go. Let's bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 14 plus 2 is negative 12. Negative 12 plus 1 is, or negative 12 times 1 times positive 1 is negative 12. Negative 24 plus negative 12 is negative 36. Okay, so x equals 1, not a solution. Okay. Now let's try negative 1. Bring down the 1 again. Negative 1 times positive 1 is negative 1. Positive 1 minus 1 is 0. Negative 1 times 0 is 0. Negative 14 plus 0 is negative 14. And negative 1 times negative 14 is positive 14, which negative 24 plus 14 is negative 10. Okay, so our remainder is not 0, so x equals negative 1 is not a solution either. Okay. So neither positive 1 nor negative 1 are solutions to this equation. Bummer. So I guess we have to try again. Let's go on to the next ones. Okay. Erase all this. Now our next ones that we are looking at, positive and negative 2, plus or minus 2. So we have positive 2 and negative 2. All right, let's see if these are solutions. Bring down the 1 again. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Negative 14 plus 6 is negative 8. Positive 2 times negative 8 is negative 16. And this would be negative 40 when we add them together. So x equals 2 is not a solution. Okay. Well, let's try negative 2. Negative 2 times 1 is negative 2. 1 plus negative 2 is negative 1. Negative 2 times negative 1 is positive 2. Negative 14 plus positive 2 would be negative 12. Negative 12 plus, or negative 12 times negative 2 is positive 24. Negative 24 plus 24 is 0. All right, so this is a solution. So x equals negative 2 is a solution. Awesome. So positive 2. There we go. Now we could keep going and keep trying these, but at this point, there's an easier way. Okay. We know that x equals negative 2 is a solution. So we can work backwards. Say this, x plus 2 equals 0, right? Add 2 to both sides. So this means that x plus 2 is a factor. So x plus 2 is a factor of our original polynomial, which was x cubed plus x squared minus 14x minus 24. Okay, we have here x plus 2. And what we have left is based off of our results from the synthetic division, which is x squared minus x minus 12. Okay. Now, can we factor that anymore, that x squared minus x minus 12? Okay. We could test all of those other numbers, but there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 more numbers to test. So why don't we just factor our original polynomial and keep trying to factor it to get all of the solutions instead? Rather than brute force and try everything, why don't we be smart about it and work through it? Work smarter, not harder. Okay. So, what two numbers, when multiplied together, would give us negative 12, and when added together, will give us negative 1? Negative 12 added together would be negative 1. Well, they multiply together to give us a negative number. Therefore, we know that one of them has to be negative, one of them has to be positive. Negative, positive. Now they add together to make a negative number. So that means when we figure out which two numbers multiply to give us 12, the bigger one should be the negative one, which we might be able to see that it is 4 and 3. Negative 4, positive 3. X plus 2. And now we have this x minus 4 and x plus 3. Look, we factored this completely. Okay. So our solutions are, just as before, okay, this one here came from testing our rational root theorem with synthetic division. X equals negative 2. This one here, right? This is zero product property all over again. So x minus 4 equals 0. Add 4 to both sides. This gives us x equals positive 4. X plus 3 equals 0. Here, I'm just going to write this out. X minus 4 equals 0, so x equals positive 4. Here, x plus 3 equals 0, so x equals negative 3. And these three numbers, negative 2, positive 4, negative 3, are all of our solutions, which we can make sure that we didn't make any mistakes, right? -2 we got from synthetic division. 4 and -3 we got through factoring. Look, +4, -3. They were in our list. We would have found them pretty quickly, but there's no guarantee of that. So we used our rational root theorem to find one factor, and then from there, we could factor out the rest. If you want to know how the rational root theorem works or why it works, there's a video on the proof of it also being posted right after this one.